In this video, I'm going to show you this amazing problem that stumped a lot of people. This is a quarter circle. This quarter circle contains two semicircles of different sizes, and these semicircles are externally tangent to each other. The radius of the quarter circle is given as 6 units. Are you smart enough to calculate the shaded region? If you're up for this challenge, feel free to hit the pause button and just check your answer at the end of this video. Whenever you are solving problems involving circles or part circles, the default first step is to always look for the centers. These are the centers of the semicircles. The circles are tangent at this point. Each time you have circles that are tangent to each other, know that there exists a line segment that connects their centers, passing through their point of tangency. Since the diameter of the larger semicircle is 6, the radius is half of 6, or 3 units. Let r be the radius of the smaller semicircle. Since the radius of the quarter circle is 6, therefore this length must be 6 minus r. The length of the drawn line segment, connecting the centers of the semicircles, is r plus 3. The central angle of a quarter circle is a right angle, which means we have formed a right triangle with legs 3 and 6 minus r and a hypotenuse of r plus 3. According to the Pythagorean theorem, the sum of the squares of the legs of a right triangle is equal to the square of its hypotenuse. Therefore, 6 minus r all squared plus 3 squared is equal to r plus 3 all squared. I will remove the diagram first so we have enough space to solve. 6 minus r is raised to the power of 2, which means we have to multiply 6 minus r to itself. Then 3 squared is equal to 9. Next, r plus 3 raised to the power of 2, which means we have to multiply r plus 3 to itself. To multiply binomials, multiply all the elements of one binomial to all the elements of the other binomial. 6 times 6 is 36. 6 times negative r is negative 6r. Negative r times 6 is negative 6r. And negative r times negative r is r squared. And don't forget plus 9. Let's multiply binomials once again. R times r is r squared. R times 3 is 3r. 3 times r is 3r. And lastly, 3 times 3 is 9. Let's simplify the equation by combining and canceling similar terms. Negative 6r minus 6r is negative 12r. On both sides of the equation, cancel out r squared and also cancel out 9. 3r plus 3r is 6r. Transpose negative 12r to the other side of the equation. The equation becomes 36 is equal to 6r plus 12r. 6r plus 12r is 18r. Divide both sides by 18 to get r equals 2. The radius of the small semicircle is 2 units long. Now we can solve for the area of the shaded region. We'll start with the area of the quarter circle. The formula for the area of a quarter circle with radius r is 1/4 times pi times r squared. Substitute the radius of the quarter circle, which is 6, into the formula. 6 squared is 36, and 36 divided by 4 is 9. The area of the quarter circle is 9 pi. Next, let's solve the area of the larger semicircle. The formula for the area of a semicircle with radius r is 1/2 times pi times r squared. Substitute the radius, which is 3, into the formula. 3 squared is 9, so the area is 9 pi all over 2. Next, let's solve the area of the small semicircle. The formula is like the previous, since this is still a semicircle. Substitute the radius, which is 2, into the formula. 2 squared is 4, and 4 divided by 2 is 2. The area is 2 pi. Finally, we can solve the area of the shaded region. The area of the shaded region is equal to the area of the quarter circle minus the areas of the semicircles. All there's left to do is substitute all the areas that we have solved in the previous steps. We get 9 pi minus 9 pi over 2 minus 2 pi. To perform subtraction easily, we'll make all the terms with equal denominators. Replace 9 pi with 18 pi over 2. And also replace 2 pi with 4 pi over 2. 18 minus 9 minus 4 is equal to 5. Therefore, the shaded area is 5 pi over 2. Thanks for watching.